Hello students, this is Mr. Baker from Ivy Tech Machine Tool Technology and Design Technology. Today I'm going to give you a quick demo in Autodesk Fusion 360. We're going to use that software to create a CAD model, to also make a drawing that can be used in manufacturing, and then also generate toolpaths and make G-code program that can be used in a Haas CNC machine here in the lab. So we're going to keep things very simple today because this software is very complicated, can do lots of things. So today we're going to be making a part that we've made here in our lab before, which is a carburetor spacer. It's a Rochester style carburetor spacer. It's an aftermarket auto part that's used to increase the performance in a automobile. So just want to let you know that that's what we're going to be doing. Okay, so hope you enjoy the tutorial. We're doing this all live today without a net, so pardon me if we have a few ums and ahs, but we're looking forward to sharing this with you. All right, so this is a drawing that shows the carburetor spacer. We made a couple changes since the version that we made that was generated with G-code that was written by hand. So we're taking this opportunity to use Fusion to make the drawing. But first we'll start out with a CAD model. Right. So first of all, we're going to start in Fusion and begin a new design. So when we open Fusion, it's already going to show a new design. So we'll go ahead and click Save, and that's going to give us a chance to give our file a name. So we can call this Carb Spacer, and then we'll save it in a folder that I've already created called Fusion 360 Milling Cam Training. Click Save, and we're ready to go. All right, so now what we're going to do is create a sketch. So we'll click on Create Sketch. This is going to be a 2D sketch. We have a navigation tool in the upper right, so we'll click on, now this navigation tool gives us the opportunity to look at our model from all different views in our 3-axis Cartesian coordinate system. So we're going to be clicking on top right now. So we'll be able to see the x-axis, which is left to right, the y-axis, which is front to back, and not see the z-axis. So these three axes correspond to the same 3 axes we have in our CNC milling machine. All right, so to get started, we're going to start out by clicking on the origin of our part, which is going to be at the intersection of the x and y axes. We're going to start with a 2-point rectangle and click on our origin and then drag it into the first quadrant. So our first dimension is 2.25 inches. Then we'll go ahead and just click Tab and then put in the other dimension of 4 inches and then press Enter. We can always use the pan command to be able to move that, and then we can click and scroll on our mouse to be able to zoom in or out. So hopefully we've got a good enough size view so you can see that now. Okay, so now we'll go ahead and continue with our sketch. So on our carb spacer, we do have some rounded arcs on the corner of each of the 4 corners of our part. So we're going to use the fillet tool that's in the sketch menu. This is a 2-dimensional fillet at this point, and that's a rounded corner. So we'll go ahead and click on that fillet tool and then click on the first corner. If we click on that, it gives us the opportunity to enter a radius dimension for that. So I'm just going to go ahead and type in 250 thousandths or 1/4 inch and press Enter. And it's giving me a warning already that we're removing constraints, and we expect that. So if I want to do more than one at a time, I can go ahead and click that fillet tool and then go ahead and click on my next corner, the next corner, and then the last corner. And then I can alternately use this little blue arrow to slide that fillet radius in or out. So I'm going to be using that blue arrow to actually just slide that down to a 1/4 inch and then just press Enter. And again, I get that same error from Fusion. But we're looking good so far. So that is going to conclude our sketch. So we'll go ahead and click on Finish Sketch, and which is the check mark icon in the upper right. And that will allow us to finish our sketch and be able to go into a 3D mode. So at this point, we can see we've got our sketch 1 defined. We can go ahead and click on that, and we'll go ahead and extrude that into 3D space. So we'll click on the extrude command, and that's going to add a depth and make our 2D sketch three-dimensional. So go ahead and put the height of the part, which is 400 thousandths, just by clicking into the blue sketch and then entering 400 thousandths and then clicking OK. Now, if I go back to my navigation tool at the top and then start to rotate that, I can see my part pivot and rotate in space. So I can see that that third dimension's been created. So let's go back to top view, and then we're going to begin to add some of the holes that are needed. So we're going to use the hole tool. And first of all, let's go ahead and select the body, which is our 3D body now. And then we'll click on the hole tool. And what we'll do then is we're going to make use of the center points of our arcs that have already been created for our fillets. So you can see that the hole toolbar opens up, and this gives us a chance to be able to define what type of hole and also define the depth of the hole and the diameter. Well, the diameter of our hole is going to be 281 thousandths, and that is because that is the amount of clearance needed for a 1/4-inch screw to be able to go through that hole. So we need about a 32nd of an inch, or about 31 thousandths. And the next thing we want to do, since we're using the same arc centers to be concentric with the arc centers, is just to be able to snap to that little white dot that Fusion shows us. And at that point, we can just go ahead and click enter, and then I'll finish making our hole. So go ahead and quickly make more of those holes by just go ahead and click approximately where that hole should be. And then moving that center point. Oh, hold on there. Come back to Earth, Mr. B. All right, we got to get out of our orbit tool here. Go back to the hole tool, which is what we need. We made just a little bit of a goof there, and if you make a goof, just go ahead and click on Control Z to be able to undo whatever you've done. So now we'll go ahead and snap that hole in place, click enter, and then keep creating our holes around the rest of the part. And then the last one. Okay, very good. So now all 4 of those holes are snapped in place. And since they're already snapped to the arc center, there's not a need to put an extra dimension in there. So for our center, there's 2 large bores in the center, and a bore is nothing more than a large hole. Now these holes are 1.5 inches in diameter, and they have a fixed dimension. So what we're going to do is go ahead and click with our hole tool active, then click about where we want those to be. So then what we'll do first is go ahead and place a dimension by just clicking on the origin surface in X, and then entering that dimension, 1.125 inches. And without even pressing enter, we're just going to go ahead and click on the Y origin, then also entering that dimension, 1.125 inches. We can also change our diameter while we're at it here in the hole toolbar to 1.5 inches, and then either click OK or enter. So that's got a dimension, and then we'll create our final hole, which is going to be 2.875 inches from the X origin on the left side of the part, and then the same 1.125 inches from the front of the part to center it. So at this point, we've created our part, and if we come back to the navigation tool, we can go ahead and see our holes that are completely penetrating through the part, and we've completed that. So now we'll go ahead, our model is complete, We can go ahead and save a new version. We had version 1, we'll just call this version 2. Great, so that's the modeling portion. We've already created our CAD model. So now we're going to move on to making a drawing. So now I'm going to click up here in this design key up here in the upper left. You're going to see all the different capabilities that Fusion offers. So we'll go down to the last one and then click drawing from design. So with drawing from design, it's going to allow us to click a drawing, and it takes a moment for Fusion to go ahead and respond to that. And it brings up the create drawing toolbar, and it's asking us to how we want to create a drawing, what type of units. We're going to use inch units, A-size paper, but we would like it to be a landscape orientation, so that's wider than it is tall. So we'll pick 11 by 8.5 and then go ahead and click OK. So at this point, it will plug and chug for a minute and create a new drawing. Okay, so now we've got a new tab open with our drawing slowly coming up here, and we'll go ahead and start to create some views and then add some dimensions. All right, so our project name is going to be our folder, and our title of our print is going to be the file name that we created, Carb Spacer. Keep it real simple. All right, so now if Fusion's going to automatically create a front view, a base view, because that's what it defaults to in the drawing view toolbar. That's not the view that we really prefer to use in Machine Tool, because the top view is going to be much more detailed, have much more of the details and contour, and also that's where we're going to be machining from. So we'll go ahead and click top, and we'll increase the size on that to a scale of 1:1. Also, I want to be able to click the icon for visible and hidden edges so we can create views that have hidden lines in them. All right, so now I want to take a moment to place that. So I can go ahead and click and then go ahead and press enter to be able to place that view on the drawing. So now I'm going to go ahead and click on drawing views, and I'll click on projected view because I want to create a front view which is projected from the parent view, which is the top. So I'll select the parent view and then just simply drag it to where I want that front view to be, and then just go ahead and then click and press enter. So now I've got a top view and I've got my front view, and you can see the hidden lines of the 6 drilled holes from the side. All right, so we'll continue moving forward then. So we need to go ahead and put some center lines on the part. But you know what, first, I know that I'm going to need to consider the tolerances. And right now, if I start putting dimensions on the drawing, what Fusion will do is it will only give me 2 decimal places of precision. And I would like to be more precise than that since we're in machine tool technology. So I'm going to go ahead and switch that to 3 decimal places of precision, and then we'll assign tolerances of plus or minus 0.05 of an inch to that. So just clicking on 0.123 to increase the linear dimension precision, and then clicking OK. All right, and then we're all good. And I can go ahead and close that document settings in my little browser here, and then keep moving forward. So next we'll go ahead and put some center marks. So we'll click on the center mark icon in the geometry controls, and then just basically select all of the hole diameters on the drawing. And that's that. And those gives us some reference points to be able to dimension from. So now I want to think about using dimensions. So I'll click on dimension and linear dimension. We'll assign some dimensions. Helps to zoom in a bit when you're doing this. Sometimes Fusion gets a little confused about where you're trying to dimension from. But again, if we make a mistake or find the dimension doesn't meet with what we had made in our model, then we'll just back up and try again. All right, so first of all, we'll do the major perimeter dimensions. So we've got 2¼ inches for our depth. For our length, we'll have 4 inches. And then for our height, that is 400 thousandths, if I recall correctly. So linear dimension, and then click on the origin, and then the opposing surface, and then click away to be able to place the dimension. All right, so we'll get that centered a little bit better. Zoom in and optimize our view. Perfect. Okay, great. So now we're going to continue to add dimensions. So we have linear dimensions that have to do with the placement of the 4 holes. So we're going to have our 2 holes on the left that are 250 thousandths from the origin in X. And then also on the right side of the part, we'll have dimensions that are going to be 3 inches, 750 thousandths from there. And then in the left side of the part and front of the part, we'll have a dimension of 250. And you can see Fusion didn't quite pick up on that correctly. So we'll go ahead and give that another shot. Clicking Control Z to be able to undo that. All right, there we go. So now we've got our 250 thousandths dimension in. So now let's go ahead and continue placing our dimensions for our other hole locations. We've got the center point of the 2 bores in Y. Center point of the 2 bores in X, or the first bore in X, excuse me. And if we zoom in, we get a little bit more control over the placement, which is handy. Next one in, and I believe that is it. Got our 250 and 250, 3 inches, 750. Oh, we got one more we need right here. So that is going to be the Y dimension. We'll put that over to the right. It's getting a little crowded. Okay, so now I believe we have all of the hole dimensions we need and also the perimeter dimensions. Great, so liking that. I'm going to go ahead and save real quick. So click the save icon, and then we'll have our carb spacer. They've added the word drawing, and then just click save. Simple enough. All right, so now we want to add some dimensions for the diameters of the holes. Now, if we click dimension, we can find a choice for diameter dimension. And that's great if you've got a single hole with that specification. But what we find is that we have 4 identical holes for the mounting holes and 2 identical bores that have the same dimensions. So knowing something about print design, we'll just instead use what's called a, not a leader, but we'll use a note. So the note is going to allow us to point at one feature, and then we can add some descriptive text that's going to let us know about how many places or repetitive features on our part. So go ahead and click on the diameter of our first hole. And we have 4 of these holes. Go ahead and click away. And you can see that information about the diameter is already put in. So I made just a little bit of a goof there. Hit undo. Come back here to text. And instead of note, we'll hit leader. So leader, it's going to give us a little leader line. And then we can go ahead and specify the endpoint. This gives us a blank text box. Now we can go ahead and type whatever we want. So in this case, 4 places. We'll use the symbols drop down list for all the nice symbols we like to use in our leaders. And then we've got the diameter symbol, and then we'll type in the decimal point. And then our diameter is 281 thousandths. And then it's a through hole, so we'll type THRU, simply click away. All right, so then we have a similar situation with the bores here. We'll go ahead and click on one of the bores out here, and we'll drop another note by just clicking. And in this case, it's 2 places, and it is the diameter symbol once again. and it's this time 1.5 inches. Hold on there. Just a little bit of, it's easier to recreate than it is to be able to try to edit it, is what I noticed there. Just pop that one in real quick. Again, I sometimes get confused between the note and the leader. So let's go with that leader again. Click right in there, 2 places, diameter. And that is 1.5 inches through 11. Okay, now we're back on track. So similar to that, we also have a repetitive arc around the edge of each corner of our parts. We can go ahead and continue that again with a note. And then we'll go ahead and click that in. And of course, look at that up again. So Mr. Baker's kind of goofing it up here, stinking the place up, as my wife says. All right, so we'll go ahead and click on that. And in this case, we've got a get this guy going again, and we've got, in this case, a 250 thousandths radius, and that is going to be typical. So we'll go ahead and put in that abbreviation, TYP. Okay, cool. So now we've got our text that describes our radii, and we've got the text that describes our diameters. All right, so feeling good about that. Now at this point, we want to add some text in here for some tolerances, and I'm just going to go ahead and do that real quick here. We don't really need to finish everything amazingly here. So we'll go ahead and hit text. We'll click where we want the first corner to be, and then also the opposite corner. In this case, say unspecified tolerances, and then for one place dimension, say that is plus or minus. Here's our symbols again. Use that plus or minus. We'll call that 15 thou. I'm just doing a little cut and pasting here. And we'll have a 2-place dimension. Call that 10. And then a 3-place dimension. Well, that's going to be our 5 thousandths that we'd like to use. And if we want to adjust the height of the text, make it a little larger, then we can go ahead and adjust that, or even type in. Now this is in decimal inches. Okay, perfect. All right, so then we're going to go ahead and put in our material as well. So we'll just pan over using our little pan command there. And then grab another text box. Hold on there. And then we'll go ahead and specify the first corner, second corner, and then type in our material specification. So that is going to be the size, which is 0.75 times 2.5 inches, and that is 60/61. Oh, let's put the length in too. We know how long the saw operator should cut the part to. 4 1/8 inches. Part's 4 inches long, so we'll allow an extra 1/8 of an inch for machining, and that's going to be 60/61 aluminum. We got that. We'll just simply click away, and then we've got our material ready to go. So aside from a bit of fumbling there, now we've got our print, and we feel good about it. So that's all the information, pretty much all the manufacturing information that you'd need to create that. Go ahead and click save. Let's get another version. So that's version 2, and that's our complete drawing. So at this point, this is all living in the cloud, or in Autodesk's cloud. So we need to go ahead and make a shareable version, and we like PDF. That's Adobe's format to be able to have a printable drawing. So we'll go ahead and click on output, and then the output PDF window comes up. We'll also check open PDF, and then click OK. And it's going to allow us to come up with some place on our computer where we want to be able to print that out. So we'll go ahead and say carb space for drawing version 2, and then click save. And then if we have a Acrobat or some type of PDF application reader on our screen on our computer, then it will go ahead and open, and we'll have a printable and emailable version of our print. All right, so there's that. So that's the second piece. So now we're done with our drawing. We're happy with that. We're going to come back to our model, and then we're going to move on to the next phase, which is going to be the CAM, computer aided manufacturing, which is going to allow us to generate tool paths and also allow us to select tools that we're going to be using in our actual machine, and then also generate the G-code that's going to be used in our machine as well. Okay, so for this, we need to think about what stock we're going to create this out of. We need to think about what machine we're going to be machining this on, and also what tools we'll use. So first, we'll go back to our top view, and then click over here in design, and again, bring up this toolbar of all the different capabilities. And this time from design, we'll pick manufacture. So manufacture, and I think in the old version of Fusion, it was called CAM, but now it's called manufacture. So this is going to bring us into our manufacturing area where we can actually think about milling this in an actual CNC milling machine. All right, so in this case, we're going to first come up with a setup. So we're going to click on Setup, New Setup. And first, we're going to have to think about what machine we're going to do this in. So we're going to click on, under Machine in the first tab, click on Select, and it's going to come up with a machine library. So what we can do is first filter on the right side for milling, because there's many different types of machines here. Additive for 3D printing, cutting for saw, turning for lathe, and milling for milling, of course. So then we'll go ahead and filter also for Haas. We'll go ahead and click in the Fusion 360 library, and there are many, many machines in here, okay? And these machines are very complicated, but we'll choose the Haas VM3. Even though it has extra axes, it is going to have the basic X, Y, and Z axes that our Haas machines in our lab would use, which are Haas VF1. So we'll pick that Haas VM3, click Select. So that's our machine. So now under Setup, we're going to choose Milling, and that's already selected. Now this is really important right here. This is our work coordinate system, or our origin and our axes setup. So we need to go ahead and tell Fusion where we want to set the origin to be. Because right now it's suggesting that we could have it in the middle of the part. But in machining, we usually like to use a part corner for rectangular parts. So what we'll do is click on box point. We're going to make sure that stock box point in origin is selected, and then go ahead and then click on the upper left front corner of the part. Does that make sense? Okay, so now we've set our origin, and that's a location on our part that we can use an edge finder in our machine to be able to find the exact point where that exists in our machine. And then tell the machine where that is, and then align our program in our actual physical stock. All right, so at that point, we're feeling good about it. So now we're going to go ahead and go on to the stock tab. And then we've got a bunch of modes here, and we want to choose fixed size box because we want to use an actual piece of stock from the rack. And we have 2.5 by 3/4 stock, which we specified in our materials. And then we want to cut it to 4 1/8 inches long, because we need to be able to machine some stock away to come up with that nice finished edge. So we'll go ahead and adjust those dimensions for extra stock on the left side and also for the depth. Our part height is actually 400 thousandths, but we need to make it 750 because we need to have some extra stock on the bottom to hold on to the part in the milling machine vise. So we'll look at that front view and then go ahead and think about our model position in Z. So we want to think about it being from the top because we want some extra stock to be able to hold on to on the bottom. but we'll use a face mill, which is a milling cutter used to mill entire wide surfaces. And we want to take off 25 thousandths worth of stock. So this way, we'll go ahead and define the top of our part as being 25 thousandths above the actual part that we want to reveal. All right, so once we've defined that, we've got extra stock on each side that we can mill off, extra stock on the bottom for our work holding to be in the vise, and then click. Actually, we're going to look over and post-process as well, because we need to define this. So this is 2 1/4 inches by 4. So we're just going to put in 22540. And then we're going to go ahead and put in 54 for work offset, or WCS offset. CNC machines usually have, they have G codes, G54, G55, that basically specify where the part is located in the machine. So we'll refer to ours as 54, and then our G code that's written at the end will have that G54, or I think actually Fusion for Haas uses G154. All right, so go ahead and click OK, and then we've got our stock. All right, so we feel good about that. Now we can see how the actual part exists in our piece of aluminum that we're going to cut this out of. All right, very good. So now let's go to the front, and we're going to think about our face milling operation. So first, we're going to go and say milling, and we're going to go 2D. I'm going to say face. It's actually face milling. We'll click on face, and then that will give us a facing toolbar. So first thing we need to do is select the tool. So this is going to bring up Fusion's gigantic tool library. And so we'll go ahead and filter that down on the right side by choosing milling, and further filtering for face mill. And then we'll choose their inch dimensioned 2-inch face mill, and just go ahead and select that. And you can build tools in here too if you've got the patience or you need to model a certain tool. The Fusion already has a lot of common tools modeled for us. We're going to disable the coolant. This coolant is usually not used on a face mill, usually used on other types of milling cutters. When we come over here to stock contours, we want to go ahead and rotate our model so that we can click on the face of the part, actually not the face of the part, the perimeter of the part that shows where the top is going to be. So we'll go ahead and mill away the stock above that, and then go ahead and have a nice finished edge. All right, so that's our stock selection. I'm gonna click over here to heights, which is the next tab. And then if I go to front, I can see this color-coded system that describes the clearance height, retract height, feed height, top height, and bottom height. Okay, so Fusion's pretty smart, and it figures out from our selections these appropriate heights that allow us to be able to mill the part without running into the vise, without plowing the cutter into the workpiece and causing a collision. So we're going to go ahead and trust Fusion to do it right, and we're just going to go ahead and click OK. So at that point, we can go ahead and see a simulation of our face milling operation. So we'll go ahead and you can see that the tool is already showing up in the model. And then we'll go over here to actions and then click on simulate, and then simply click the play button and then see our milling cutter and see that it's going to be simulating the milling of the top 25 thousandths of stock. So that's all good. Feel good about that. Go ahead and close that up. Come back to that later. All right, so now we want to go to another operation that's going to be 2D contouring. We want to be able to mill away some stock and create the outside contour. Well, Fusion's already shown this face mill, but that's not the right tool. So we'll click into our select tool window again, filtering for milling. This time we'll choose flat end mill, and then we'll search for a 1/4 inch. So let's go ahead and search, and we'll use this flat end mill that Fusion has in the library that has a flute length of 750 thousandths. Click select, it's got a little tool holder in there. Everybody's happy. All right, so now we're gonna get and select on the geometry tab we want to select the contour selection. So we'll select this bottom contour, and then Fusion knows where we want to mill. So we're feeling good about that. We'll get the heights. Love what Fusion's doing here, so not going to go ahead and continue that. And then also, if we wanted to do roughing and finishing, we could specify that here with roughing passes, stock to leave. But in the interest of time, we're going to keep on moving and just go ahead and click OK. All right, so love it. Let's go ahead and move to the next operation, which is going to be to mill out these two bores. So we're going to use Fusion's 2D adaptive clearing. Use the same tool for that, which we love already, and then press select. We're going to go ahead in the geometry tab and then go ahead and define the bottom of these two bores, and then go ahead and keep on moving here on heights. And again, Fusion is got a great idea of what we want to accomplish here. It's got appropriate heights that are going to allow us to avoid collisions. And then we're just going to go ahead and press OK. We'll check passes. And I notice on the optimal load here, we need to reduce that diameter down from what was defaulting, which is 1/4 inch, down to about half the diameter of the cutter. So Fusion won't give us an error. And also in this case, I'm going to remove the stock to leave, which is suggested there, to be able to define roughing and finishing passes in the interest of time. So we'll click on OK. Then we feel good about that. And then finally, we can start to see a little bit of a model of what that is going to look like after the milling happens. All right, so two more tools. We're going to have drilling that needs to happen. So first is going to be a center drill. So we'll go in here into our drilling, and we'll select hole making, and then also center drill. So when we get center drill, and then we'll go ahead and select number 4 center drill, which is the same type we have in the lab. Click select, and then click easily just be able to select the 4 holes that we want to drill. Now, right now, if we click on the front here, we can see that Fusion is defaulting that to drill all the way through. Okay, and a center drill is just meant to make a really small indentation in the top of the part. So we'll click on height, and then for bottom height, we're going to offset that. It wants to drill all the way through, which is not how a center drill works. So we'll add in 250 thousandths, which will bring the bottom of the drill depth up, and then so we can just get the tip of the drill in. All right, click OK. So we're loving that. We've got our center drill now, and then our final drilling operation is going to be the through drill. So we'll go into our select tool function, and then we're going to search for 930 seconds. So we get to 930 seconds. Go ahead and pick our 930 seconds drill. It's in the Fusion tool library. Click select, and then simply go ahead and select those holes once again, all 4 of them at once. Now the cool thing about Fusion, it has a little selection for optimized order. So even if you select them in a certain order, it's going to reorder them for the lowest possible cycle time, which is great. All right, so we're loving it. And we're going to go ahead and click on the heights tab. And again, we can see a simulation of how far it's going to go through. So right now it's going to drill down to the bottom of the part, and the tip will touch the bottom. That's not adequate. So we're going to go ahead and click drill tip through bottom. And then also to make sure that we don't have terrible burrs in the bottom, we'll add a breakthrough depth of 50 thousandths so that all 4 of our drills then will penetrate all the way through the part, and then hopefully take off most of the burr that will be on the bottom of the hole. At that point, we'll just go ahead and click OK. And then we have got our entire tooling operation and all of the tools that we need. You can see over here in setup, we've got a face mill, tool 1. Tool 2 is our 1/4 inch end mill for our contouring and adaptive clearing operations. T3 is our center drill. T4 is our 930 seconds drill for the actual drilling. Now you can see here, Fusion is showing us that we've got some chatter and some bad finish. It's because we're not doing finishing passes. Now it allows us to endlessly tweak the nuances of all the different passes that we want to do. But that's not the objective of today. So we'll go ahead and get ready to do a simulation. So first of all, let's go ahead and save this because we've done a lot of work here. We'll call this V3 now that we've moved on into manufacturing phase. And then go ahead and simulate. So we're going to click on setup, and then we're going to right click and then choose simulate. So in the simulate toolbar, we can see, and we're going to go ahead and make sure we have the tooling is transparent. If it's not, you won't be able to see through the tool. It's not very useful to just have the tool hiding the part. And in this case, our other selections are good. And what we can do is go ahead, we can see the simulation. If we move our speed, let's go back to our setup. Actually, we're kind of goofing this up. Starting on the first, getting set up here, and then we'll move our speed down. Then click on, we're having just a little bit of a goof here. Let me go ahead and close this guy up here. Click on setup, close this for just a second, and then come back here and get this all. We're so close to being done, everybody. All right, here we go. You're gonna say simulate. And then we'll go ahead and slow our speed down a little bit. We're on the first face, and then we can go ahead and press. We're having just a little bit of an issue here. And it wants to jump through really fast on our first one. All right, so let's look at our face milling operation. And press. Anyway, we're having just a little bit of issue with that happening. So anyway, we are having just a little bit of an issue on that, but in any case, I think we did pretty well otherwise. We'll try it one more time and see if we can't get that up to snuff here. And we'll go ahead and bring this back to the beginning. Go to previous operation, and then go ahead and press click. Here we go. All right, ladies and gentlemen, so now we're seeing our face mill operation happening. Go ahead and speed this up a little bit by moving the slider to the right. And if it's in the center, my understanding is that it will be at the same exact rate that it would be in the machine based on Fusion's speeds and feeds that have been defined. See our adaptive clearing. We can speed that up a little bit, get through it more quickly. And one thing to note is that the spindle on a CNC mill doesn't actually move left to right. Comes the drills. And now we're done. All right, so again, we've got some chatter, we've got some finish issues, but the thing is, we were able to create our entire tooling operation, all the tool paths to be able to mill that part for our finished operation. Okay, so that's the whole point there. And close up our simulation, give it a save, and then now we're going to finish up our demo by using to be able to generate the G-code. That's why we're here, right? So we're going to go ahead and hit setup, right click, create NC program. We've got our program name and number, and go ahead, and I think it's actually supposed to be 40. Our library is, we're going to use capabilities as milling. Vendor is Haas Automation, because that's the company. And then we're going to pick a machine here. So we're going to use the pre-NGC. This is the classic Haas controllers that we have here. This is called the post processor. So this is what's going to optimize the code for our actual machines and the way that, and write the G code in the way that machine wants to read it. We're going to use sequence numbers, which are our line numbers. Our G code lines begin with N and then a number. So line number, the first line number would be N10, second would be N20, and so forth throughout the program. And that will help our controller keep track of our program, because it's going to be very, very long. All right, so then we're going to go ahead and click on post, and then post. If we've got our check mark for open NC file and editor, then it will hopefully open in Notepad or some other text editor. And we'll say don't show again, hit 0. So now our NC code is successfully posted. So we can go ahead and click view NC code. And then WordPad is going to be an application on this computer that can read text, because a G-code program is nothing other than text. So let's go ahead and exit setup here while my Windows computer tries to install Visual Basic, which we don't need. All right, so here's our G-code program. Tools 1, 2, 3, and 4. We've got some notes, and they're in parentheses, so those lines are not going to be executed. And then we have all the different operations: the face milling operation, the 2D contouring, the adaptive clearing, which has got many, many lines of code for circular and linear interpolation. It's going to divide those circles into impossibly small little straight lines. And we have many, many, many pages of code so that Fusion can optimize that milling to be able to do it as quickly as possible and make it as geometrically accurate as possible. Okay, so that's it. All right, so that's our whole process. So again, we created a model. We made a drawing with dimensions, with all the manufacturing information. We chose the machine. We defined the stock. We chose the tools that were used, and then generated toolpaths, and then generated our G-code program. Okay, so I hope you've enjoyed that demo. One thing I wanted to mention, that just like we didn't use any finishing passes, we also would need to be able to turn this part over and mill the bottom, to mill the base away of the stock that's being held in the vise. But all we need to do is add an extra setup in Fusion to be able to do that. But in the interest of time, we want to go ahead and show you anyway. All right. Well, I hope that you've enjoyed this demo, and I hope that you learned something about Fusion 360 and about manufacturing using what a great tool this is by Autodesk. All right. Thank you so much.